Hi everyone, today's topic we're doing is 6E, interpolation and extrapolation. This graph here is really good indications of what interpolation and extrapolation is. Interpolation is when you have a data range. So for example, in this case, it's between this data and this data. Anything in between is interpolation. Anything outside is extrapolation. So in this case is we're looking at the age of a person comparing to their height. So as we know that kids grow over time, but it's only in a certain period. So for this, for people's height, it's normally during your puberty period. Okay, so outside doesn't make much sense. So the explanation here is kind of questionable. If you don't believe me, I'll give you a few examples. So we expect to stop growing about what, 16, 18, okay? Well, in this case, if you're 20 years old, if you have the graph here, you're over 2 meters already. Well, you're about 2 meters tall. So does it really make sense here? Well, let's say if it makes sense, what about in your 30s? You are about 2.6 meters tall. I don't think it makes any sense here. So a lot of times when we do when we look into extrapolation, you need to think about whether it really makes sense. If the right hand side of extrapolation doesn't make much sense, how about the left hand side? Well, let's do when you are 1 years old. Are you 1 meters tall? Probably not. Hey, so that doesn't make much sense either. So for a general term, you need to be careful about using extrapolation. Interpolation normally okay, but depends on how your data. If it's like really strong, it should make a lot of sense. You could potentially use the line of best fit to predict some of the values, but outside you do need to use your professional judgment to think about whether you could use those projections. Okay, so in this case, it doesn't really. All right, let's look into another example here. This scatter plot, we talk about the average pay for male and female in different countries. So to see whether there's a pattern there, see whether male go up, if male's income go up, female's income go up as well. So this is what we're looking at. So the graph here is basically the interpolation graph because it's kind of inside the range, but we can also extend that a little bit. So we are going to extend that a little bit because so we can do the extrapolation part too as well. So I'm just going to go like this. Okay. Now let's answer those questions. What was the average annual female income for a country's average male income is 45. So let's do 45 here. Yeah, let's go up and hit the line, and then we go from the line across to here. It looks like about what there is 10 close to 28. Let's do 28. Okay, so it looks like female is 28,000. Okay. The second question is not really looking at the graph, not really looking at where the projection. It's more looking at counting. So how many countries have average female over 25 grams? So 25 grams here. We look at how many data point is actually over 25, so we can count that. So we don't not care about 25, so we talk about those ones. 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 countries. Okay, so predict female's income given by male. So this one we can actually use the lines, pink. Okay, so 20 is here. Here we can do a cross. About what, 22? So wait, what? 20 for male. That is look like 22. 22 for females. Oh, they actually have higher. Anyway, so for 40, now is 40 up here somewhere. So go from here to here is about 27,500. Okay, it's close to that. 60, so 60 is here, up in here, and then we do across. It look like what, 38? So 38. Okay, so predict the male income using a female. So we need to use the one on the left hand side. So let's do orange. So 25 here, 25 in the line. Looks like here. 31. So 31,000. 30 here. Where it look like 49,000, and then 35 here, go up across. Oh, that one look like 65. Okay, so easy question. All you need to do is read the diagram. But another thing to discuss here is, can we use those information? Can we use we're basically using interpolation for most of the questions. Can we use outside? This could be a because it's incomes. It could be not. We need to see whether it makes sense or not. But that depends on your judgment. It could be or could not be, depends on what you're projecting. So let's say, well, if male is 70 in Australia, well, female, if 70 here, female is about 36, doesn't really make much sense. So it always there is argument whether we should using or shouldn't. But in this case, we only using it in interpolation, so it should be okay. We're not talking about extrapolation, so yeah, no worry for this question. Okay, so let's move on. Whoop, something wrong with the iPad, doesn't move. Okay, cool. Now the next one is life expectancy. So we're looking at the data is given from 1900 to current years. So inside this range will be interpolation, outside will be extrapolation. So in this one, all you need to do is find the life expectancy. And whether the interpolation or extrapolation. Okay, so anything inside that range is interpolation, outside is extrapolation. That's easy. So all you need to do is I'm going to use LE to represent life expectancy, and all you need to do is just type in calculator times a year minus 353.78. So you can quickly work those out. So 0.21 times 1900 minus 353.78. You should get about 45.22. Okay, so that would be interpolation, yeah. Anything inside will be interpolation. This will be extrapolation because it is before 1990. 2000 is also interpolation. We're not 2030 yet, so it's extrapolation, and this also interpolation. Okay, you can work the rest out. The thing I want to bring up is whether it makes sense if you use extrapolation. Okay, so I give you one example here. If we do, let's say, 1700s. If we do 1700s, if you put in calculator, your life expectancy is 3 years old. What does it mean? You live in 1700s, you expecting to live 3 years in your life? That doesn't make sense, yeah? What about if you do years 3000? Your years 3000, your life expectancy will be 276 years old. So that point makes sense. We don't know what the future look like, but I think with data in this case makes sense. So between 1900 to 2020, it probably makes sense, but outside it probably not. So those are the cases we probably need to look into. Again, just a quick recap. Interpolation is likely to make sense. Extrapolation probably not. You need to make sure that you think about it. you do some calculation to see whether it works or not. Okay, so you got a few questions to do is 1, 3, 6, 8, and 10. Thanks for watching. Hope you enjoyed this video.